Hey everyone, and welcome back to another PChem recitation video. I think this video will be relatively short, but I'm hoping to cover some stuff that are some common misconceptions and some things that might help you on your homework moving forward. Okay, so real quick with Hooke's law, I wanted to point out some stuff. So if you've taken physics in the past, which I'm assuming most of you have, you've probably learned that Hooke's law is this F is equal to negative k times x, and that is true. That is how you generate the force for Hooke's equation when you're doing spring stuff. Remember that in PChem, we're not looking at force, we're looking at energy. So when you're looking at that, it's going to be energy is equal to kb over 2, which kb, remember, is your spring constant, and then it's going to be r minus r naught raised to the second. So why is this different? And I've had a lot of you question this and come to me asking questions about that. The big thing to note is that the change in E is equal to force over the change in distance, which if you take the integral of that, that's where this equation actually comes from. So please make sure that you remember that, especially from that homework that Dr. Pearson handed out. It's really important that you know the difference between the two and you use the correct one in the exam or any future homework. Okay, next thing I want to talk about is the Morse potential connection to Hooke's law. So based on your journals, a lot of people don't really understand why we use it or how it's used. So the reason that we use Hooke's law, it is something like we did on that last slide. It is very clearly defined. And basically, we can get an exact value at our R min amount. So here on this graph, we have R min is going to sit at about 1.22 or somewhere in that region. So right around that value, our Hooke's equation provides a really good estimate of what is going on with our energies. On the other hand, we have our Morse equation. So Morse equation is really complicated. It's super complex. You can't really see it in here because I've zoomed in so much on this part of the curve. But if you remember, it looks something like that, and then it goes back up and comes out. So there is a ton of different factors that go into shaping that equation. To solve it can be really complex and can take a lot of time. So Hooke's is a great way to do things quickly and efficiently when you're really close to R min, and that is where the connection comes from. The farther away that we get from R min, the more separation that we have here and the more error that we're going to get. So you need to make sure that you're really close to R min in order to use Hooke's law. Okay, so another thing I wanted to talk about is some ways to use Excel. So I wanted to talk about the dollar sign, how to use a double click, and how you can edit some graphs. Okay, so I'm going to talk to you guys a little bit about how to use some fun stuff in Excel. So I'm actually going to clear these real quick, and we're going to talk about how I went about doing this. So let me delete these cells, and that is cleared. Okay, so in this column, we're going to say that this is our reading, and then we're going to have this row be our baseline. So in this case, we're going to have something where, for example, we used a standard and we got some sort of reading value that we're going to look at in a second. So what I'm going to do here is I want to generate a list of random variables. So you can just do this equals rand and between. And here you can type in, so I'm going to do 5 to 62 and press enter, and then drag this down, and that's going to copy that function all the way down. Now, if you're using the random, you want to make sure that you actually special paste these, because every time you enter a function, it'll regenerate it. As you just saw, I pasted and all these values changed. So I'm going to go ahead and delete these so that we can use these guys for what we're going to use. So if you noticed earlier, I used the between 5 and 62, so I'm going to say our baseline was 3. Just as an arbitrary unit, whatever experiment you were doing, you would hopefully have a baseline. Again, I'm just creating random numbers in this case. So then we're going to say that the count 1 is equal to that, and because we have that, we can actually use this corner feature. So as you can see, there's a little cross there right now. So if you double click on the left mouse, it'll actually drop it down to whatever the list is next to it and fill it in automatically. So it'll change the numbers and do all that stuff for you, which is pretty neat. So now I want to get a actual value for all of these counts. So we have our baseline, which means that whatever standard we used was a reading of 3, so we want to subtract that out. So I'm going to have a corrected reading, and what I'm going to do here is I'm going to say equals, and then I'm going to grab this guy right here, and then subtract this one. If you're on a Windows, you can press F4, and that'll put the $signs in front of the C value and the 3 value. If you're on Mac, I believe you have to type that out individually, but if you press enter, it'll go ahead and do that. Now the reason that we put $signs around it is if we go to the center, or to the edge again, and double click it and drop it all the way down, it'll freeze that cell, so it always subtracts from this cell right here. So that's pretty neat, and we can get some pretty cool corrections really quickly from that. Okay, next thing that we want to do is look at something like an average. So we can say equals average, and then you take the population here and press enter, and that really quickly provides you the average. So another thing that you can get with Excel, as you saw, I moved that cell and nothing changed. As long as you move cells like this, it'll automatically update whatever your formulas are based on what you just moved. So you don't have to worry about updating your formulas. So that is why it's really important to actually use other values. So if I had to change something here, it would automatically update here. A lot of you on your homeworks didn't do that, you just plugged in straight equations, and that can get really messy really quickly. So another thing that we might look at in this class is standard deviation, or standard dev. In Excel, the function for that is just standard dev, and then usually we're going to do .p. Really, there's some minor differences between .p and .s, but you can typically use .p. And that stands for of the population versus of the sample. So when you get that, you get your standard deviation for that population. Cool, so that's some pretty quick ways of going about doing stuff. Okay, the next thing I'm going to talk about is how to generate a graph and how to manipulate it a little bit. So if we go into insert, and then we're going to add a graph here, and go ahead and put that. So on Macs it looks a little bit different, but this is what it looks like on a Windows. So you're going to select data, you're going to add a new data set, and then we're going to add our X values, which we did for our counts. And then for our Y values, we're going to put in our corrected values. And really quickly, it pops out this nice looking graph. Now, I tend to hate the lines in it, so I tend to delete those, so you can just click on them and delete. And then I like adding a border. So if you go to the border here, do a solid line. Typically, I go with something that looks gray, so it matches the axes and looks good. Now, another thing that you can do is you can actually select the axis that you're looking at and change the minimum and maximum value. So, for example, when you were looking at the Morse potential and the Hooke's equation, you could change the axes so that you could see a little bit better the local minima that you were actually looking in on at. So let's say we want to look at that area between 10 and 20. So you can just manually enter 10 and 20, and it will update the graph so that you're only looking at that set of data. So that works both on the x-axis and the y-axis. So you can edit that to be whatever you want it to be. Overall, those are the big things with Excel that I think you probably will need and will help you on your homework coming up. So hopefully that helps.